Hello, welcome back to another video lecture on basic algebra. Today we're going to be talking about scientific notation. So scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form. Scientific notation is generally written in the form of a times 10 to the n. So a few rules here. A is always going to be some number that is between 0 and 10. It will always be less than 10, but it's allowed to be 1, and it's allowed to be positive or negative. So we say the absolute value of A is between 1 and 10. The next thing to note is this number here will always be an integer. So it could be positive or negative, but it will always be a whole number. There will never be fractions or decimals. So let's look at a few numbers and determine if they are actually numbers in scientific notation. So the first number we have is 1.47. This is not in scientific notation. The next one we have 21.2 times 10 to the second. This one's also not in scientific notation, and the reason why is because this decimal is over here, so A is larger than 10. With this first one, we didn't have a times 10 to anything, so that's why it's not scientific notation. This next one is 0.01 times 10 to the negative third. This one's also not in scientific notation. And the reason it's not in scientific notation is because, once again, this number is not between 1 and 10. So let's look at this one. We have 2.1 times 10 to the first. This one is in scientific notation. In standard form, this would be just the number 21. But since it's in scientific notation, we would write it this way. Notice that this number is between 1 and 10, and this is an integer exponent. The last one we have is 1 times 10 to the 0. This one is also in exponent or in scientific notation. The exponent is an integer, 0, and this number is between 1 and 10, being allowed to equal 1, so it's okay. Anything to the power of 0 is just 1, so this number is actually just simply 1. So let's talk about the process of converting from scientific notation to standard notation. So to do this, first we start by looking at the exponent on the 10. So if the exponent is positive, we move the decimal place to the right. And we're going to fill in any empty spaces created with the zeros. So here we've got two examples. 4.139 times 10 to the sixth. We're going to move this decimal 6 times. So we're going to get 4, and then the first decimal movement gives us the 1, second decimal, third point over. So we would do something like that. Here, 3, 4, 5, 6. So our decimal point is going to be there, and we end up with these zeros like so. This gives us 4,139,000. So here we have 3 times 10 to the 8th. We're going to start off with 3, and then we're going to move this decimal 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And we end up with our decimal point there. Note that we did move this to the right. 1, 2, 3, 4, 5, 6, 7, 8. That's our last point that we moved it. So if the exponent is negative, we're going to end up moving the decimal place to the left instead. Then we fill in any empty spaces created with zeros. So here we've got 1.2 times 10 to the negative 2. So if we look at our 1.2, and we move this decimal place left twice, we go 1, 2, we end up with 0.012. This is the additional empty space created. Now if we look at this one, we have 6.67 times 10 to the negative 7. So what we're going to do, 6, 6, 7, and then we move it 1, 2, 3, 4, 5, 6, 7. 0.1, 2, 3, 4, 5, 6. And this is the number that we end up getting. This is an incredibly small number, and we would not normally write something like this in this standard notation. We would change it to scientific notation. And on the topic of changing to scientific notation from standard, let's talk about how to convert from standard notation to scientific notation. So to do so, we start by looking at the decimal place. We want to move the decimal place so that we end up with a number between 1 and 10. Once again, it's okay for that number to be 1, but it cannot be 10 or more. The number of places we move the decimal gives us our exponent for our times 10. And the direction determines the sign of the exponent. Moving it left makes the exponent positive. Moving the decimal right makes it negative. So let's look at some examples. Our first example that we're going to do is 0.00137. So if we move the decimal place, 1, 2, 3, this gives us 1.37. And notice that we moved it to the right 3 times. So we moved it 3 times, so when we say times 10 to something, we've got this 3. This is the number of places we moved the decimal. And we moved it to the right, so this becomes negative. So let's look at our next one. Our decimal place is here. We're going to move it 1, 2, 3, 4. So we get 1, could say 1 or 1.0, times 10 to the 1, 2, 3, 4. Since we moved left, this stays positive. So now let's look at this, 0.1. This is going to be 1 times 10. And if we move the decimal, we move it 1 time. And we moved it to the right, so we make this a negative 1. Our last example is 467. We start with our decimal place here, and we're going to move it 1, 2. So we get 4.67 times 10 to the power of 2. Since we went left, we made a big number smaller. This stays positive. So, I hope that this is a good explanation on scientific notation. And I hope that you learned something from this video. I hope you enjoyed the video, and we'll see you in the next one. Goodbye.